Well, let us follow our previous video and see if we can teach our SUMO robot, our fusion robot, to stay inside the SUMO Rink. First, we want to look at a repeat loop. So we look at a loop, we get the repeat while true. This is the same loop as we used in the standard example in the previous video. Now, next we'll want a new logic element we haven't used yet. It's an if-do. So we've got if something happens, this is what we do. So we want another logic element for a comparison. We'll use this one and plug that in. And we want to read optical sensor on port 1. So we go to sensors, optical distance sensor, and we go to read optical center and we put that in there. Read optical center is not A0, we've got our sensor on A1. So we read optical sensor. If we're going to be in the middle of the rink, we're going to have over a number of 600. Remember, in our previous example, white was around about a bit over 1,000 and black was around about 200. Add them together, you get about 1,200. The value average of those is 600, so we use 600 as an element that's halfway between 200 and 1,000 roughly. So we'll go down to maths, and we want to put in a value here of 600. Oops, 600. And if we get a value in A1 which is greater than 600, we know we're in the white area, and what we want to do in that case is to go drive forward at speed, well, at speed 50 we'll say. Okay, so from the white area we'll go forward to speed 50. But when we go forward and find the black, then we want to do something different. Okay, so again, let's look at the logic. It seems that Modern Robotics haven't got an if then else in their version of Blockly, so we use another if statement. And again, we'll look at logic and use this comparison one. If we'll go to optical distance sensor, read optical distance, put it in there, port A1, and if it's greater than or equals 600, so this will be less than 600. We want to go to the maths element then, to put a number in our comparison. So if it's less than 600, it's hit the black on the edge of the rink. So the first thing we wanted to do is to go backwards and back away. So we've got room to turn around. So I'll get our fusion robot to drive backwards from -50 at say 1 second, seems a reasonable amount. And then we want to rotate left. It'll turn away from the black line, rotate left at 50 for 1.5, that seems probably okay. And that's our program to keep our fusion robot inside the SUMO Rink. It checks to see that if it's greater than 600, it just keeps going forward. If it's less than 600, it's found the black area, it goes backwards, it turns, and then it'll go forward again. So in the white area, it'll go greater than 600, forward at 50, greater than 600, forward at 50, greater than 600, forward at 50. And if it's in the black area, doesn't go there, comes in here, less than 600, drive backwards for 1 second, turn round, it's in the white area again, so it keeps going forward. So that's our program. Let's see what happens. Now this is interesting. I've got a new version of the operating system. This has changed up here, and it's now forcing me to save the program before I run it. This is a good practice, and it's an interesting change from the previous version of the operating system. So that's an upgrade from Modern Robotics. Here our fusion robot goes to the black line, pulls back, turns. Oh, now I'm using very strong lights, and that flipped back when it wasn't near a black line. It saw the shadow of itself, and it decided that was a black line and flipped backwards. But normally for the rest of the video it'll only do that when it actually finds the real black lines. Good fun.